Alright, welcome to the video/presentation on trigonometry and parts of a triangle, summary of Unit 14 of Delmar's standard textbook of electricity. So let's just jump right into it. What makes a triangle? So a triangle is a closed shape with three sides, three angles. All angles need to equal 180 degrees, and only one angle can be at or above 90 degrees. So you have a lot of different types of triangles. They can be acute, right, or obtuse when measured by angles, or equilateral, scalene, or isosceles when measured by sides. But in trigonometry, specifically in the trigonometry that we've been doing, we deal with right scalene triangles because they have a 90-degree angle and they're even-ish. It's easier to get your opposite and your adjacent with that. So parts to a triangle in trig. Quick pull up paint. So that was really bad. So your sides. You have side A and side B. Doesn't matter what you label them, just as long as you label them so you keep them straight. These are two lines that come together to form a right angle, which this here is your right angle. It's going to be represented by a box. It's an angle exactly 90 degrees with two lines coming together and meeting perpendicularly, which that's what this is. Your hypotenuse is the longest side of a triangle, which creates two other angles smaller than 90 degrees, which each leg. So this is H for hypotenuse. And this connects with A to create angle X, connects with B to create angle Y, is what we'll call them for this purpose. You have two acute angles, which are X and Y here, that add up to equal 90 degrees because a triangle has to be, let's see, degrees equals 180. It has to be 180 to be a triangle. It can't be above, it can't be below. Now, sine, cosine, and tangent. Just going to get this out of the way and put these up here. So, sine, cosine, tangent. There. So your sine, your cosine, and your tangent are different measurements of a triangle using different sides or different angles. So for example, like as I go here, or maybe the next one over, sine of a triangle is a measurement of its opposite side and the side that is bisected, or the opposite side, which is the side that is quote-unquote bisected by the middle of the angle over the hypotenuse. Now what are we talking about here? So the sine of y is equal to a over h, because this quote-unquote bisects a, which bisect is a term for quote-unquote dissecting something in two or splitting it in two, and then the hypotenuse, which that's where you get your so from. It's opposite over hypotenuse, which I go into explaining these all a bit more later. Your cosine, I'm going to stick with y here for this example, is your adjacent, which is the angle next to it, so in this case B, over your hypotenuse. So the best way to remember it is you have three lines in a triangle. One is always going to be opposite and one is always going to be hypotenuse. So your adjacent is always going to be the odd one out. Then your tangent of y is going to be your your opposite over your adjacent. Again, you know that you have your hypotenuse. We're not going to worry about the hypotenuse. Your opposite is directly across from the angle, and your adjacent is the one left over. Yeah. So how do you remember this all? It can be quite complicated, so here's how she recommends remembering it and how I recommend learning it. So katoa, what we went over here. So can be thought of standing for sine That was a really bad S. Sine over hypotenuse. You know, because it's your sine over hypotenuse. Pretty simple. Cosine above hypotenuse. Because again, your cosine has it over the hypotenuse. So let me think on that. Yeah, so again, a lot of it is just remembering which lines are which. So for sine, it's the one that cuts it. For the adjacent, it's the one right next to it. I think that makes sense. It makes sense in my head. If it's not making sense, it hopefully should later. So your tangent over adjacent. Okay, so here's what I was talking about. So with the sine over hypotenuse, the cosine above hypotenuse, and the tangent over adjacent, what you're trying to remember is you're remembering over / above, they're interchangeable, and then you're remembering what it's over. So obviously if it's over your hypotenuse, then your hypotenuse is your denominator, which is the bottom half of a fraction. So same thing here. Your cosine would be above hypotenuse. Obviously A is already spoken for, so it's going to be B. And you know that it's going to be B as well because that's your adjacent. And then for tangent, you can't use hypotenuse anymore, so it's got to be over your adjacent. And then obviously your only one left there is sine, which is what I talk about here as well. Each measurement of sine, cosine, and tangent, you use it twice in 3 sets of 2. So let me... Don't save. Shit. Shapes. Perfect. Okay. So, do a line there. And a line there. Label is sine, cosine, tangent. Line there. Line there. A. Well, actually, instead of writing A, because that can get confused with adjacent, we're going to write op for opposite, adj for adjacent, tan for tangent. So your sine is going... The way that this works is in each column, only 2 spots can be filled out, and same thing goes for the row, only 2 spots can be filled out. So your sine is your opposite, and your oh shit, I did that wrong. Wow, I did that really wrong. Let me just fix this real quick. Hypotenuse. So it's your opposite over and hypotenuse are getting used here. Okay. Cosine is your adjacent and your hypotenuse. So hypotenuse has been used 2 times, so it can't be here. But adjacent didn't get used here, and opposite didn't get used here, so you have to use them here. And then by setting it up this way, you always remember that your opposite will always be on top, your adjacent will be on top if it's above hypotenuse, and hypotenuse will always be on the bottom. You kind of got to think of it like a logic puzzle. But yeah, by using this strategy, you can generally pretty easily remember it. You know, I'm not going to say you'll always get it, but I have not messed it up on a test so far, and I don't plan on changing that because of the fact that I used that strategy. Now, for finding your angles, you use the SOHCAHTOA method. So, you know, again, coming back to the other drawing that we had. We're going to do, instead of doing A and B, we're going to do L, M, H, X, Y. So, if we're trying to find our measurements for angle Y here. So, if we're trying to find our sine, that's so. So, you could find it by doing the over the hypotenuse, but the way that it's done is you find your opposite, which again, it cuts through the opposite, and you throw that over your hypotenuse. For cosine, that's your adjacent. That's the one next to it. Because, again, both of these angles have two sides next to them. It changes between which angle you're looking at, but they're always going to have an opposite and adjacent and a hypotenuse. As long as you know which one is your hypotenuse, which your hypotenuse is always the longest side, then you can always find your opposite and your adjacent, just depending on where your angle is. So again, your cosine then is going to be M over H. I'm going to just write down the K here as well. Because again, it's your adjacent over your hypotenuse. Now your tangent is opposite adjacent. That's okay. That's how they intend for you to remember it, is OH, but again, it can be tricky. But yeah, anyways, this is L over M. So the way that this works, and the only way that this does work for you, is if you know the lengths of your sides. If you know that your opposite is 10 and your hypotenuse is 15, you do 10 divided by 15, that's 0.6 repeating 7. And then you multiply that by the inverse. I don't know why I said reverse, it's inverse. Of sine, which is 42. Just to bring back over here real quick. AC. So 10 divided by 15. That's 0.6 repeating 7. Then you multiply it by the inverse of sine. Shit. Hold on, let me clear this. So 0.67. Okay. Technical difficulties here. Okay, that gives you 42, which is what I got here. Alternatively, if you have one angle, what you can do to find another angle, I don't know why I said alternatively, but once you find your first angle, which in this case we have 42, you can easily find the other one by taking 90 and then subtracting from that other angle. So, yeah, 90 minus 42, that's 48. Now, why does this work? A triangle always will have 180 degrees. We already know that there's 90 degrees being taken up, so we have a total of 90 left over. And then, yeah, you take your 90 here, you subtract the angle that you already know, you get the angle that you don't know, and now you know both your angles, which is useful for if you need to find your sides. Now, the issue with finding your sides is you can't just go off of angles. You have to know one of your sides. Now, the first way that you can find your sides is by using the Pythagorean theorem, which this is if you know two of your sides and you don't know the other one. So, with the Pythagorean theorem, a squared plus b squared is c squared. We all know that. However, if you need to find b squared, what you can do is subtract b squared for both sides. You get a squared equals c squared minus b squared, I think. Yeah. And then you can subtract c squared from both sides as well, which it doesn't wind up coming out to exactly how you would do it, but it comes out to c squared minus a squared equals b squared. Now, if we were doing this properly, oh wait, no, that does come out correctly, because essentially at this point then we just reverse the signs, because this would be a positive, a negative, and a negative. Then you just reverse the signs. Then you get c squared minus a squared equals b squared. And to find that, then you do the whole, you find the square root of every number. So then it becomes c equals a, or sorry, minus a equals b. And then let's say you get x equals b. Yeah. Then you have your answer for b. So that's how you find one side if you have two sides. Now, to find another side if you have an angle, what you do is you take your sine, cosine, or tangent, depending on, you know, what values you have. Obviously, you go by your denominator in this case, which, once more, your denominator is the bottom half of the fraction. For sine and cosine, their bottom is going to be the h. Again, so that looks like sow. So, ka, toa. Again, these last letters are your denominator. I'm just going to write down den again. It's your denominator. I'm going to write it like that. But then your first letter is your numerator. It's always either going to be opposite or adjacent. Opposite is always on top. Hypotenuse is always on bottom. A switches between them, just depending on what you need from it. So what you do is you find that angle, or sorry, you take your sine, cosine, and tangent of the angle, and then you multiply it by your denominator. So for example, say you have 45 degrees again, or again, I don't know where we've had 45 degrees in the past, but 45 degrees, and you multiply it by 5. So what that's going to be is, if I remember correctly, sine 45 parentheses times, what did I say it was? 5? Okay, 3.5 repeating. Okay. So that gives you the side that you're looking for at that point, which, yeah, let's say that that's our opposite side. No, let's say that's our adjacent side. Then you would do the opposite. You would do the tangent of this angle, or of one of the angles. I forget which one is which sometimes. But yeah, again, it can be complicated if you don't know what you're doing, which, you know, obviously fucking statement of the century there, but I think if you do your best to try and remember the things that we went over here, and you genuinely study this, you should have a fair understanding of it and a fighting chance with the test. Now, that should be it. Yeah, I'm going to write my paper for composition. I hate that class. And then after that, we'll see what time we have for a blueprint study guide. And, you know, we'll see things from there. You know, worst case scenario, blueprint, you know, we have that after lunch. So if I don't get a blueprint study guide out tonight, then if you want to swing by early during lunch, swing by the classroom, then, you know, we can do like maybe a group reading of Unit 1 and Unit 13 or something like that. The big things to remember with that are your square root of 3 for 3-phase, and then your 5.77 for a 3-bank open delta transformer, and then the 86.6 for a 2-bank open delta transformer. And then aside from there, it's all just figuring out, which numbers do you need to multiply and divide by. Which, yeah, I mean, I know personally I did not do well on that transformer test, but I feel like after we went over it tonight or today still, I got a better understanding of it. So I hope that also helped you guys get a better understanding of it. But again, if you need the help, I will be more than happy to help people study over lunchtime. But anyways, that is it for this video. Thank you for watching.